We use custom gestures to determine custom behavior by our users on the device. Imagine if you want to find out if your user is drawing something similar to a circle, or if you want to find out if they're pointing in a certain direction. All of those we can actually achieve them by custom gestures. And in this lesson, I'm going to actually show you how to find a way that your user has to draw a certain direction on the device, and if that direction is correct, they get a notification saying that they have drawn in the right direction, and if it is not, they get a chance to redraw it. This could be useful for any situation, like when you want your user to draw a projectile in a video game, for instance, or anything that you might come up with. Now, in this lesson particularly, because it became a slightly longer code, I decided to actually develop the app for you in advance so I can actually show it to you. So if we go to Xcode and into Simulator, this is the end result that we are going to see. The app has a very simple interface. Every time you redraw, you get two different points, a start and end, and your user can draw in here or move their tab. And as they move their tab, they get some sort of an indication of which direction they're moving. And if they do draw in the same direction from a start to end, similar to this one, they will get a notification saying that you found the direction. Any other thing, it tells them that they have to try again. Now, in my example, only thing that really matters is the direction. You could actually expand on this and make it in a way that it has to start from this point or somewhere near this point and be on the right direction. So that's what we're going to do. It's going to be a slightly longer piece of code, but I think it really helps you understand and master everything that is out there about gestures. With that, let's go ahead and get started. I'm going to go to Xcode, start a new project, call it Custom Gestures. And the first thing I'm going to do is I'm going to add my interface items. So I have a label up there. That's going to be my result label. It shows us how well our user has done. So that's my result label. I'm going to make it like that really quickly. That is the result. I have a UI view, which my UI view is essentially where your user can play the game. So that's the playable area essentially. And we have a button. This button redraws the different items, the start and end. So now I'm going to say redraw, and the redraw is going to be maybe like that. I'm going to make the background to have a slightly different color so we can see everybody else. I have another label. This is going to have a background color such as this, and it's called start. And I have another label, and this one actually says end. So let's go ahead and add these outlets. So this is going to be result label. This is going to be draw view. This is going to be a start label. This is going to be end label. And this one is going to be a redraw action. That's about that. That's all we needed to have in our storyboard. So let's go ahead to view controller. I'm going to format this a little bit better because I know that, we're going to have a lot of code to write. That is our action. And this is our view did load. Maybe I'll clean that up as well. And I need to have a few other things as well. One of them is that I need to add a new class that is going to be my gesture recognizer. So I'm going to say class. This class, I'm going to call it my custom gesture, and it's a subclass of UI gesture recognizer. So that's one. And then in my view controller, I'm going to have to get one of those, an instance of those. So I'm going to say var my simple gesture. That's going to be gesture that's going to be of the type my custom gesture recognizer. I need to have two locations because we need to be able to randomly place these two. So I'm going to get two CG points for those. I'm going to say var point 1, that's going to be a CG point, and I'm going to have a var point 2, and that's going to be a CG point as well. And the next thing I want to do is I want to be able to redraw these two labels every given time that I need it. So I'm going to go to redraw action, and in my redraw, essentially I have to do this. I have to say a start label dot center to become some new value, and I have to say end label dot center to become some new value. And those new values, we have to essentially produce them randomly. So I'm going to go in here and say, let's first make a random location for each of these two numbers. So let's first produce a random location for point 1 and point 2, simply because these 2 points are the direction we have to go through and also are where these two should be placed at. And that's going to be a little bit of a long code, but bear with me. So I'm going to say let ran x. Let's make that become an arc4random uniform with an upper bound of drawView.frame.size.width. The moment you do that, you will end up getting an error, and that error is essentially because the type of the variable here is not the same as what the function is expecting. This happens a lot on Xcode, and you get a different kind of error. The error says the type of value is ambiguous without more context, simply because it cannot translate it to the type of function. Most often when you have this kind of error, it means the type of variable is not the same as the function is asking. So to fix that, at least in this very instance, I'm going to say, well, let's do a uint32, which is what you expect, of this value. And I'm going to get myself a little bit more space because I still need to write quite a bit of code. So now we got an arc4random, but that random value is a uint32 itself. So if I wanted my random x to be essentially a CG float, which is what I want it to be, this is not going to give us an error because it's going to say one side of this equation is a uint32, the other side is a CG float. And the suggestion that Xcode has is to essentially cast this value into a CG float, which is what I'm going to do. Let me get myself a little bit more space still. And now what we have is we have a CG float value of this random location, which is based on the width of the draw view. So we got the x taken care of. And I don't need to have this explicit annotation. And in the interest of saving a space, I'm actually going to remove it because we know it is a CG float now. So now I'm going to get the same thing, copy it, say this is y, and this is height. And obviously I'm going to apply both of these to make my point 1. So point 1 becomes a CG point of these two values, random x and random y. And my start label can essentially be at point 1. So a start label center goes at point 1. Now we have to redo this process once again for point 2, and that's going to help us with the end label. So I'm going to go ahead and say, let's copy both of these one more time. Again, this time we don't need to do the let part, and we actually have to convert this into variables because we are trying to change them, and we are redoing the random generation again. Remember, if we did it once, both of these will be at the same point. But since we do it once and we place the first label, then we do it again and we place the next label, they end up being at the right spot. So next one is going to be point 2, which is going to be a CG point of these two locations, ran x and ran y. And of course, the center of the end label becomes point 2. So if it all works well, by now we should have an app that when we run it, every time we press the redraw button, it redraws 2 new locations for our labels. For the locations of the labels, I should mention that I didn't really account for the borders. If you want to be super careful about it, you can make sure that they never go in and out of the view. But for now, I think I can just live with this. So now every time I press the redraw button, I get 2 new locations for start and end. So now we have these 2 taken care of, and I'm gonna have to move on with my actual gesture work. So redraw action is taken care of. Let me fold that, and now I'm gonna go to my view did load to add the gesture. So I'm gonna say my simple gesture is my custom gesture, and that's going to have a target. That's the default super class init from UI gesture recognizer. I'm going to say target is self, and the action is, let's say, a selector for something called gesture action, which we don't have yet. So I'm going to say, let's add that function gesture action, and that's that. And it has to be exposed through Objective-C. And once I have that, I'm going to go ahead and say, well, draw view dot add gesture recognizer, and the gesture I want to add is my simple gesture. Now let's see what we need for our gesture to actually do for us. What we need to do is this. I'm going to write them as comments. Find the angle between points 1 and 2. Find the angle between a starting and ending point of the gesture and compare them against each other. So we have to find the angle between the 2 points, which are essentially these 2 guys. We have to find the angle between where the mouse is moving. Then we have to compare them, and if it was within a certain tolerance and acceptable value, it means our user has done well. If not, it means our user has essentially messed it up. So to do that, I'm going to first go through my gesture work, because for our gesture, we need to have this thing, the angle between a starting and ending point, which is not a default thing from any gesture. So we have to build that ourselves. So I'm going to go ahead to my gesture in here, my gesture class, and I'm going to say I need some variables. First of all, I need an angle, and I'm going to say that is a CG float, and it's got a default value of 0. The next thing is I need to find the starting and the ending point. So I'm going to say var a starting point, that's going to be a CG point, and var ending point, that's going to be a CG point as well. Now, every UI gesture recognizer can override the 3 main touch functions. So I'm going to say touches began. That's one of the functions we're going to use. And let me reformat it properly. I need touches moved. That's another one we're going to use. And let me reformat that one as well. And let's get myself a little better space. And touches ended. And soon you will see that most of the code that we have to write here is actually very simple. So the simple parts are these. A starting point becomes touches dot first dot location in view. So now we got the very first point based on where the touch began. Then we get the ending point in touches ended. In touches ended, I'm going to say that is exactly the same thing as before. First dot location in view, and the view refers to the default view of the gesture. And since we are only applying it to one view, it doesn't matter for us. Otherwise, you could actually have a custom init to take care of this part for yourself. So that's taken care of. Then the next thing is this. We have to find this angle between these 2 different locations, the starting point and the ending point. And more importantly, we have to set the state of the gesture. So I'm going to say in the touches begin, we're going to say a state is going to be UI gesture recognizer.state dot began. So our gesture is now active. State with an E at the end. And then in the touches ended, I'm going to say, well, a state is going to be UI gesture recognizer dot state dot ended. So now we know where it begins and where it ends, and everything in between is the moved part, which we really haven't done anything about it just yet. Now let's go ahead and calculate the actual angle between where we started and where we ended. The first thing I'm going to do is I'm going to assume my user is going to run this several times. So every time that they begin, I'm going to set the angle to 0. I'm going to say angle is 0 every time the touch begins. So every time at the very beginning, we don't have any angle. Every time the touch ends and the state ends, let's go ahead and say angle. And this is a bit of a mathematical formula. I think I've mentioned it somewhere else as well. If you don't know it, it doesn't really matter at all. I don't know it either. I went online and I Googled it. So it becomes an arctangent 2 of the difference of the y's and the difference of the x's. So essentially ending point dot y minus starting point dot y, and the next argument of it is going to be ending point dot x minus a starting point dot x, and that's all there is to it. So this formula is going to calculate the angle for us, and it has an error for me for some reason. Let me see, what does it say? Ending point value of CG point has no member t. Where is t? Oh, okay, sorry. So y, not t. Okay, sorry about that. That was my bad. And yeah, that's about it. So we now can calculate the angle. Before I move on to actually test this out, I want to show you a very simple way, not a very bright way to be honest, for showing the direction where your user is actually drawing. Here is my strategy. Hear me out. When I begin moving, for everywhere I move, I draw a little UI view with the color red. So every time I start moving, for everywhere my mouse goes or my tap goes, I draw a little box, and that box is going to be added to this view, and at the end I'm going to remove them. So when the touches ends, I'm going to get rid of them. So let's see how I will do that. I'm going to go in here in my gesture, say variable temp boxes is going to be an array of UI views, and it is going to be empty by default. So these are the temp boxes, or temp, let's call them temp guides, better name. So every time we go to touches moved, and that has nothing to do with the touches began or the touches ended, only in the touches moved, I'm gonna say let's call it this guide. I'm gonna make it a UI view of a UI view with a frame, and that frame is going to be 0, 0, and a width of maybe 5 and 5. All right, these numbers, they don't really matter. I'm gonna say this guide will have a background color of UI color.red, so it is quite distinctive. And this guide, most important part of it, dot center is touches dot first dot location in view. So we place them exactly where our touch is currently. And this location is obviously optional, so we have to force unwrap it to make sure that it actually exists. And then I'm gonna say view dot add subview guide to it. So by now we end up adding so many guides to our view, but we should also have a way of removing them, and that's why I have that array. So I'm gonna say temp guides dot append guide. So this way we end up making sure that we have stored them somewhere and we can get rid of them. So when do we want to get rid of them? Obviously when the touches end. So when the touches end, I'm gonna say, well, for any in temp guides, do this. Any dot remove from super view. So anyone in the temp guide, which is all the guides that are currently stuck to the view, remove them from super view. Once you did that, say temp guides is empty again. Okay, a lot of code. So by now we should be able to see at least these guides. So that's a good thing because it kind of gives me a little bit of confidence that I'm doing the right thing, having the visual feedback usually. So now if I do that, perfect. It's actually showing me that I'm actually drawing something at least. Whether it is in the right direction or the wrong direction, I don't know that part just yet, but that we'll figure it out real soon as well. So to get us started with that, let's go ahead to our gesture function, which is here. And I'm going to say, let's print two values. One value is the direction between the 2 points, which we have to calculate. And the other one is the one that our gesture has produced. So I'm going to say, let's call this one current angle. And that's going to be arc tangent 2, very similar to the one we had before, of 0.2. Remember this one, ending point. 0.2.y minus 0.1.y, and the other side of it is going to be 0.2.x minus 0.1.x. So that is going to be the angle currently presented between these 2 points. And then we also have 0.1. I don't know why I constantly make this mistake. And then we have the angle that we received from our gesture being called my simple gesture. So I'm going to print some values. I'm going to say print, and in the print, I'm going to say a triple quotation marks for a large string, essentially. And in here, I'm going to say I have these. One of them is going to be current angle is, and the value for it is current angle. And then I'm going to say gesture angle is my simple gesture dot angle. So we end up seeing both of these values, and then we can find a way for essentially comparing them. We had to find the angle between these two, we found it. We had to find the angle between the starting and the ending of the gesture, we found them. The last part is comparing them. Let's run it again, and once it comes up, we should be able to draw on the screen and see the values of both of them. If that works, it means we're in a very good shape. So now, everything crashed. Why do you think that happened? Now, this is something that we're gonna study in far in advance, in 15 sections from now. But for now, if you go to your little debugger window, it will tell you that two values are nil. 0.1 and 0.2, no one has decided about them. And that's simply because these two are the default values, and the default values are actually nil. Nobody has actually defined them. They only get defined the very first time the redraw action is being pressed. So one of the solutions is we actually call the redraw once we go to view did load. So in the view did load, I'm going to say redraw self. And if we run the application now, we should be able to see the values of both of these. But I want to mind you that still something is not going to work the way we expected it. So as we run this, we get so many gesture angles that are 0, gesture angle 0, gesture angle 0, and then sometime at the end we get an actual gesture angle. And the reason for that is this. Our actual angle gets calculated here when the touches end, which is when the state of the gesture is ended. So in our gesture function here, we have to only do this when the gesture has ended. So I'm going to say if my simple gesture dot state is UI gesture recognizer state state dot ended, this is the only time that we actually have to do this comparison. So let's run it again, and this time it will only happen when our touch ends, which is essentially when the gesture ends. So now when I let go, we see that. And of course, the two numbers are widely different than each other because one of them is going 180 degrees or 3.14 something around the pi number, and the other, the direction I drew was from the top to bottom. But if I go something like that, the numbers are kind of very, very similar. And let's deal with that part now. That part is going to be the easiest one. In here, in my gesture function, let me get myself a little better space so I can only show you this one. So I obviously don't need any of the print values. What I do need is some sort of a boundary or a tolerance. So I'm going to say let tolerance to be, let's say 0.2. And then in the ended state of our gesture recognizer, I'm going to say, let's find the difference between these two, the angle from the current one and the angle from the simple gesture. So I'm going to say, let angle difference, for instance, that's going to become my simple gesture dot angle minus current angle. So we're going to subtract these two from each other. Now here is something that you have to keep in mind, that these two values could have a different signature. One of them could be positive, one of them could be negative. And because of that, we have to get the absolute value of it. You have to get the difference between them irrelevant of the signature. And if that was the case, and if we got their signature free value, I'm going to say if angle difference was smaller than tolerance. So if the difference between these two angles was smaller than 0.2, then that's what we want to do. So here I'm going to say, if that was the case, then we called this one result label, if I'm not wrong. Yes. So we're going to say result label dot text is going to say you found the direction, and result label dot background color becomes UI color dot green, and in the else all the opposites happen. So in the else it says try again, and the background becomes red perhaps. Now there is a little error in here. It's saying you're comparing a CG float with a double. So the very simple solution is we make the tolerance to become a CG float as well. So everyone is now a CG float, and that error should go away. Perfect. Let's rerun this application now. We don't need to print anyone anymore. We only have to be able to see the direction. And now it's the moment of the truth. So I'm going to redraw. I want to get a better space. Perfect. If I go from a start downward, it's going to tell me try again. If I go that way, it's going to say try again. If I go from end to a start, it says try again. If I go from a start to end, it says you found the direction. If I go to a start from somewhere similar to end, it says still good. If I go further, it's bad. So you can actually decide about this tolerance on your own. How much is 0.2 for you worth it? And you can actually calculate the 0.2 to be 0.2 multiplied by 180 divided by 3.14. So it's about 11 degrees. So 11 degrees is a very narrow margin. I'd say 0.2 is actually a good number. I came up with it randomly, but I think it's a good number that we found. So that's about that, a complete custom gesture recognizer benefiting from touches begin, moved, and ended methods, and applying it on top of a draw view to find a specific direction. A lot of the things that you end up doing with custom gestures, they end up being more about mathematics than programming. For instance, if you want to find out if your user is drawing something similar to a circle, then that essentially becomes a lot of mathematics, finding sample points of where your user has clicked and trying to find the center, establishing a center based on that, and then based on that finding out if most of them are within the same vicinity. For instance, a drawing like this would kind of be a circle, but a drawing like this would not be characterized as a circle. And yeah, that's about it. I hope you can manage this on your own, and I'll see you in the next lesson.